Okay, let's start. It's 3:20. The number of students in this class and the other section is like day and night. The other class, people bring seats from the other place they cannot sit. Over here we have like 1, 2, 3, 4, 5, 6, 7, 8 people in class. Okay. Anyways, we'll see what happens. So, again, because of the screen, I'm sitting over here, and I apologize for that. Let's start with a quick review on what we have. Yeah, much better place to sit. Quick review on what we've talked about last time. Very first, the last thing we talked about last time were static stuff and alignment and things like that. Just going to go through, we talked about static methods in here, right? Yeah, I'm going to just go through it because it's important to know. So the statics that we talked about is essentially we said that at any C version of static variables are block scope or function scope variables that they have limited visibility with respect to the scope they're in, but they have the lifetime of the application. We gave an example using a function. We created a static variable in there, and we said that the static variable that is created over there, the line 17 over here that has a static variable, will get essentially executed the very first time the function is called. And S will take the value of 0, and after that, line 17 is completely ignored. And S exists in far, and every time it's called, it's going to run it over and over. So essentially, when I am running the function far in here, which has static variable in it, the very first time that I'm coming in, S will have the value of 0, and that's what is being displayed. And it comes out, but when it comes out of the class, S will not die. So the second time it comes in, S will hold the value that it had before, that was 1, and it prints that one, and it keeps going like that. So every time the for function is called, it adds 1 to the value of the static variable, and that's what we call static variables. They are used for many cases, for many things that you want to do in C language, but what interests us is C++ and how C++ actually deals with static member functions and member variables. We gave an example for a class that had a static. So let me put this one over here. Then to demonstrate what we have to kind of continue on what we've talked about last time, we have a class over here, container, that has a regular attribute called data, and then it has another attribute that is static called CNT. Unlike regular variables that you can actually initialize them within the body of the container and set them to whatever you want to set them, the static variables cannot be like that, because static variables are essentially class variables, not object variables. Class attributes, not object attributes. Therefore, they belong to the class, not the object. Because of that, the constructor, whose job is to create an object, has no authority on initializing the value. Therefore, we need to actually manually initialize the value outside of the class. That initialization is usually in the CPP file or right under the class. So it essentially tells either the CPP file or under the class. So it essentially sets the value of the static or shared or class attribute to an initial value. And after that, we can always change the values in all the functions that we have. We said that we can actually set methods of a variable to be static. When we say method of a variable is static, that essentially means the method is a class method and not an object method, which again goes to the category of, it falls to the same category of the static variables. And because for the class itself you have only one method, the static methods cannot access the object methods or object attributes because it's one-to-many relationship. If, for example, in here I want to set mdata to something, that's impossible because it doesn't know which one. If there are 50 objects of container, there are 50 mdatas. It doesn't know which one to set. Therefore, you can't do it. Okay? So it can, yes? Doesn't make any difference. This, what is this? The current object. An object, you have 5,000 of them. And because of that fact, you don't know which object you're dealing with. Again, the word this, fantastic. The word this is completely invalid in a static variable because there is no this. This is in an object, not in a class. Class doesn't have a this because there is no object. So I can actually access the value of that one. And you can always call a class method or a static method of a class when even nothing is created, because the method exists within the class and not the object. If I run this program, we will see that it actually starts 3 years later. Okay? It actually starts. And when it comes, as you see at the very first, it says number of instances using the class. Oh, my class spelling is wrong. My apologies. Class static method is 0, so I did not instantiate anything, and I ran it, and it worked nicely. Let me just fix this one too, because I remember I copied and pasted it. There we go. So now if I get in here, 3 instances are created. If I say c0.display, that's going to be 3. It shows actually the display over here is showing the number of instances. We know it's 3. I could have used the class method too. If I dynamically create one and I do display, now I have 4. And if I delete that one and I do display, I have 3. So every single object that is created and destroyed essentially sets the value of the static, and therefore I can count them. And at the end, I know I have 3 of them, and when the object is over, it's going to go back to 0. And that was static variables. Now, in the other class, they actually said, why the heck we want to even have a static method inside a class? Like, why? Because the static attributes are accessible from any method. Why do I need to actually have a class method set? Reason is that class methods are usually created to essentially do what is related to the business of the class, but is not relative to the objects. For example, if I create a utility class that is handling string stuff, none of the values that you see over here, as you see in here, the constructor is completely deleted, which means this class is not even allowed to be instantiated. So all I have over here is utility methods. I want to be able to use them to do my string stuff instead of using string header file. If I want to do that, then this is a good way of writing it. In OOP345NAA, because we didn't know what statics are, we created a class, we instantiated the class, And then what we have done, we created a singleton. Did we create a singleton? No, it wasn't a singleton. We instantiated the class and made it accessible everywhere. That's how we use the utility. And because we did not have enough knowledge to create a singleton essentially is a class that can be instantiated only once, like cout. You cannot create 2 instances of cout. It's only one. Even the constructor is private. You cannot even create an instance out of. Well, anyways, I can show you later on how singletons are recreated. It's out of the scope now, but we'll see. Anyway, so this is a good thing to do. So it's a good example for it. And as you see, all the functions that are written over here are actually dealing with all the good stuff you're supposed to do with a string, but they're all static variables. And if you want to use them, you have to say CSTR, scope resolution, and the method. Therefore, no conflict with any other methods written anywhere because they belong to a specific class. And again, because they are static, they are utility, and they are not instantiated over it. So that's B, static method, or I'm going to write over here, class method. Review. So now we are going to talk about pointers and pointer reference and stuff that we have used in OOP244. But I'm going to quickly go through my IPC lecture of pointers. 244 people, I think, that had me, I think they've already seen it. But if you are not my student, it's a good idea to actually look at this. So give me a second. Let me prepare this. I'm going to bring it to someplace private so you don't see what I'm doing. So this is my main that I'm going to use to actually give you the examples. So if you see stuff over here that is using IPC notation for structures, yes? Go ahead, please. Repeat that, please.
If a static variable is copied by value, does it still retain that value? It's passed by copy.
I don't see why copying something like if you have a paper that you have some notes on it, you make a copy and give it to your friend. Will anything change to your paper?
Because if you copy, because if you pass by copy, instead of passing it by like through a pointer.
Or okay, if you pass it by okay. So if you pass a static variable by value, you are passing, thank you. If you pass a static variable by value, you are extracting its value out, and you have no access to it. So you know what the value is, you cannot change it. If you return the address or reference of a static variable, then you actually have access to the static variable in another function. That's actually one of the very common practices to like, for example, you are creating an array, and you're creating a class to represent an array, and you are returning the elements of the array in an index operator, the reference of them. Okay? So when you do that, what happens if they put a bad reference? I have to return garbage, right? So one of the ways that they do that, index operator, they create a static variable of the same type of the elements, and they call it garbage. If they put an index that is wrong, they send the address of the garbage out. Because it's static, it stays alive. And and also it returns garbage. So because the value is, even if they return its reference, nothing happens. Because if they change the value, they are changing the value of the garbage. So returning the reference out, very normal practice. You will have access to a static value variable within your outer scope. If you just receive its value, then you have its value. You cannot change it. I hope that answers the question. All right. Thank you. Now, very quickly, by quick, I really mean quick. I'm not going to fiddle around this thing too much. So what happens is that this is your memory. The memory starts from 0 and goes up to whatever. Money in your pocket, I always say, the more you pay, the more RAM you have. Every byte in the memory is indexed with a value, or with a sequence number. That sequence number we call address. So essentially, when you say your address of this thing is such and such, it means if from the beginning of memory start counting the bytes, when you end it, that's the address. Now, when you create a variable, essentially the compiler and operating system, hand to hand, they allocate a little place over there with the size of the variable that you want, and then you put a tag for it. That becomes the name of the variable. Anything you put inside the variable actually goes into the variable. And if the variable type is different, the size of the memory that is allocated for it will be different. So if you put a value in one variable, the value will cover the whole thing that it has, and the same thing for the other one. That's essentially what we have as variables that you create in your program. Okay? Now, let's go back. Now, we can actually, let's say we want to design the pointer ourselves. So we essentially want to create a variable whose job is to hold other variables' addresses. That's the pointer, right? So it's a good idea to actually call it a pointer so we don't, it's easier to just call it pointer. So I'm going to call it pointer PTR. And we know size of the pointers is equal for everything. It doesn't matter you have an address of a Parton complex or you have an address of a small house somewhere. The size of the address is the same. It's the target that is different. Therefore, the PTR over here, I'm going to give it 4. Remember, we are designing it. We want to see how the pointer, if we design what we're going to get to. So essentially, when I want to put some value in it, that pointer, like an integer, you can actually put a value in it. But if you put a value inside the pointer, you essentially mean that the pointer is pointing to somewhere, right? So that address better have some valid target. You don't randomly just put something somewhere. If you want to put something in it, you want it to be something valid, like 108, that is the address of var. And therefore, you can access val remotely using its address because you can now carry its address around. That's a pointer. Are we okay with this? The problem is that when the compiler creates a pointer, the pointer that is, creates a variable and it names it, there is no way for us to know what the address is. So we cannot just create a pointer. We have to create actually an operator that tells to the compiler, extract the address and give it to me. So essentially, I need to be able to say PTR is equal to address of var. Are we okay with this? Are we okay? So doing that, we're going to make it 108. And then I need to have yet another operator to actually put the pointer in front of it and says, I want target of this pointer to be set to that. Because if I set the pointer itself to a value, it's a variable. It's going to gain a value. If I want to put the value where the pointer is pointing to, I have to say, put the value in target of PTR. Therefore, 2345 will not go to PTR, will go where PTR is pointing, which is var. Therefore, 2345 is there. We're good? You all knows this. I'm just knowing this. I'm just giving you kind of a quick review of pointers before I'm going to go banana with them. Okay? So essentially, if I print the variable, the value will be printed. If I print target of PTR, again, the value is going to get printed. But if I print the PTR itself, then the whole address where the variable is will be printed. Are we clear on this? We good? Okay. Again, I told you, I'm like full throttle, I'm just going. Okay? Now, I want to do the same thing with the double one. So I'm going to say the PTR is the address of the double, therefore 132 will go to it. Now I'm going to say target of PTR is equal to this one, hoping that I can actually put that value inside this DVR, dvar. There's a problem here. Last time when I put the value to the target of PTR, var was written, and it was only 4 bytes. This time I'm putting something bigger that takes 8 bytes. How the heck PTR is supposed to know what is the size of the target? There is nothing in here indicates what PTR is pointing to, right? So it's flawed. It's not going to work out. So our design sucks at the moment. We have to fix it. To fix this problem, what can we do? Instead of just saying pointer, I can say integer pointer PTR. By saying something like that, I'm saying PTR is not only a pointer, but also it's a pointer whose job is to only point to integers. Therefore, when I actually extract the address of an integer and I say set it, it actually knows what the size of the address, size of the target is and puts it to the proper value. And I can do the same thing with the double. Now I can say double pointer dptr, which is essentially another variable now. And now I say the target is that, and I put the value. It puts it gracefully because it knows the target of dptr is a double. And everything else will work perfectly. Are we OK with this? Oh, really? OK. The reason I was rushing it, because this is an IPC 144 lecture, I was trying to, OK. So I'm going to slow it down to this point. Are you OK? You want me to go back? We're OK? Because we're almost done. OK, OK. So now. Pardon me? Is anybody online? Did anybody talk? Is anybody online? I heard that somebody's talking. Let me check. Yeah, I have somebody online. While you're online, I appreciate that you're joining, but this is a lab. You're supposed to be in class. OK, thank you. Anyways, listen and enjoy. But next time, please be in class. Thank you. And let's continue. Oh, that's not the one. I just minimized something. I don't know how to maximize it now. This is the one. There we go. OK, so now, but that's easy. Like, so essentially, this is what I want to do. Essentially, I want to say integer, say val is equal, something like that, integer val, right? Then I want to say integer pointer IPTR. Now I'm going to say IPTR is equal to target of val, right? Now if I say, address of, not target of, address of val, and now I can say, is it capitalized? Yes. And now I can actually say target of IPTR is set to 1, 2, 3, 4. So when I say cout val, what is printed is 1, 2, 3, 4. Are we OK with this? So that's essentially what pointers are. Any questions now to this point? We're all good? All right. But that's too easy. C wants to make it difficult. Because of that fact, where's my presentation? Oh, there you go. Because of that fact, they actually said, hey, we're going to present pointer by an asterisk, which means you can't say int pointer. You have to say int pointer PTR, double pointer PTR. And that's why the asterisk actually belongs to int and a double. We OK with that? And they said address of is too long. Instead, I'm going to use an ampersand. Therefore, I would say dptr is address of the var, and the address belongs to that. Are we okay with this? The problem is that they see they don't have enough stuff and say, okay, the heck with it. We're going to make target of asterisk 2. So now, target of dptr is that, and target. So as you see, it now works like that. Are we okay with this? Now, how do we identify which one is what? Which one is target of, which one is pointer? Okay? When, not this one, let's go back. How do I go back? When asterisk makes sense, when you look at the asterisk, it says, oh, okay, that means multiplication. It has nothing to do with pointer or target of. So when you look at the asterisk and say, that's okay, that's multiplication, right? When the asterisk comes after a type, integer, asterisk, employee, asterisk, whatever asterisk, that's pointer. Never call it asterisk. Always say it what it is, because when you say it, you will remember it. So now you say integer pointer something, like integer pointer, double pointer, struct pointer, or whatever. Sorry for the struct, because it was for C class, that's why we have struct. Otherwise, you can just say employee pointer. Are we good? Now, if you look at the asterisk and you say, what the heck is that? That means it's a unary thing and it means target of. So essentially, if it comes as a unary operator, like -5, not B, asterisk C, that asterisk means C is a pointer and you want to know what the target is. Therefore, if I say A is equal to target of P, that asterisk doesn't make sense. It means target of P. Don't call it asterisk P. If now target of T is X. Now A is equal to B multiplied by target of C. And now E is equal to target of M multiplied by C multiplied by C. Okay? So say it, and it's going to go crystal clear. Are we okay with this? So the question is now, how the heck this thing worked? The reason is that I had a header file over here, and I say define target of to asterisk, define address of to ampersand, and define pointer to asterisk. So I literally replaced them before compilation. And then it works. Okay? Just to show you, it is literally that. If you say it properly, you'll understand it. If you say ampersand A, then you're screwed up. You have to say address of A. Say it, say what it means. Read it as it means, and then it's going to go into your brain, and you have no problem with it. Are we okay with this? Good? Now, and I have an answer. Wait.
It's easier when you want to read it, but it would be hard when you want to actually implement it.
No.
You don't know.
The reason is that you never said it the way you were supposed to.
Really?
If you did it, it's going to fit in place. Have you ever had any problem writing an address on an envelope? You said, should I write my letter in here? Or should I write? No. You know the address goes on envelope, and you know the letter goes inside the envelope. You know that.
Yeah.
It's the exact same thing. When you have a pointer, you know its job is to hold other things' address. Why is anything wrong with that? It just makes sense. It's something that is supposed to carry other things' address. They are just unsigned integers. Don't give them extra credit. They have just one difference. I'll mention what is the difference between a pointer and an unsigned integer. Why do we even have pointer? The problem is the reason for it is the size of the target. An unsigned integer is our first pointer that we created. Actually, I think, I'm old. I think Pascal programming language pointer was like that. It didn't have a type. You could not actually do any arithmetic with it. But C's pointers, they have type, which means you say integer pointer. Now, if you add 1 to an integer pointer, 4 will be added to it. Why? Because it knows what the size is. If you have a double pointer, you add 1 to it, 8 will be added. And that's how arrays came to being. An index of an array is essentially what to add to that pointer. And the name of the array is simply a pointer.
Yes. Yeah.
When you say array name 3, it means take the address inside the array name, add 3 to it. If it's a double, then 24 will be added to it. Therefore, it jumps to the 4th one. Everything goes, again, if you say it properly and don't give it extra credit. The reason is that as soon as they get into the subject of pointers, ooh, a monster is coming.
Exactly,
That's
yeah.
not the case. It's just the variable. Like when you learned about integers. Was it scary? No. This is a pointer. Its job is to hold the address of an integer. That's it. Don't give it extra credit. Done?
Yep.
You good?
Thank you.
Okay. Pointers and arrays. Again, that's another C thingy. I don't even remember what was I saying? Let me see. I hope that again, we start with, we said that we have memory and we create a variable, one variable is created, right? That's what we said, right? So when you create an integer pointer, it's the exact same thing. You have a variable and you can set to that variable, get the address, you put the value and all the good stuff are there. Are we okay with that? When you create an array, the difference is that 5 variables are created when you say AR5. And there are 5 integers. Are we okay with that, everyone? Okay. Now, so what's the difference? The difference is that I cannot call this an AR, because if I say AR, which one is AR? Because of that fact, what they do, so, and yeah, and the index and stuff, you know that. But that's not what's happening. Behind the scene, what happens is that a pointer will get created called AR, and then 5 integers. And the address of the first one goes into the pointer. That's how arrays are designed in C. And when you say actually AR0, it means from address 108, go 10 bytes further. Therefore, it's the first one. If I say 108 plus 4, 12, therefore it goes to 112. So it knows where the, okay, let's take a picture. I wanted to pose for it. Anyway, we good? All right, but it's being recorded, my friend. Okay, you can see the recording on the, anyways. So it's AR5. So now, because of this fact, if you actually say target of AR is equal to something, even if it's pointer, it's going to set the first one, exactly like a pointer. If you say AR2 is 444, it's like that. Or you can even say target of AR plus 2 is 555. These two are identical statements. There are no difference between them. You can actually use all your arrays like that. When I learned that thing for almost 2 years, I was using that notation for my arrays, okay? Because I wanted to like show off. I know what arrays look like in C, okay? And yeah, and then the company I wrote the program for said change all those things before we fire you, because people get confused, right? What you shouldn't do that. You shouldn't write cryptic code, okay? Yeah, so if I do 555, it replaces that one. It's the same. Are we okay with this? Questions? Suggestions? Yes.
I have a symbol for it.
Oh yeah.
Let's say, for example, that you have, I don't know if you've ever seen CDs or mixtapes. Usually songs are 4 minutes.
Okay.
So basically it's the same process. Every time you start at the beginning and then you want to skip 1, 2, 3, it jumps to 4 minutes, and so on.
Exactly. Exactly the same. Yes, exactly. Now, just to interest you on this, I have to show you this one. So this pointer thing, yeah, and that's why I brought this down. I actually didn't want you to see that pointers thing at the top that I included. But anyways, so in here I'm going to say, what should I call this? Fake pointers? Fake pointer thingy. And it's not C++, it's C, people, okay? We are not talking C++. All right. So now so again, if I have integer AR5 over here, and I initialize it to 10, 20, 30, 40, and 50, if I do something like that, then I can simply say cout target of AR plus 3, and what is printed over here is obviously 40. We're okay with this, right? 2 seconds, my dear. Okay, I'll do it right now. Okay, so I can do this. Take a look. I'm going to say integer pointer p is equal to AR. So I have a snake with 2 heads now. I have a snake with 2 heads now. I have a snake with 2 heads now, which means P and AR are the same array now. Didn't we say that this is what an array looks like? Can I show it, do you think? Didn't we see this is what an array looks like? What's the difference? AR, I'm going to create a P, and P is pointing to the same place. So it's an array with 2 things, right? Now, so now I can say P plus equal 2, right? Now I'm going to say C out P 0. What is the output of line 8? Pardon me? 30. Okay? Because C is stupid. It doesn't know. You have an array. It's a target. It doesn't know what is the size of the array. We know that C doesn't know what the size of the array is, right? And therefore, to make the lady happy, I can actually say over here, C out target of P minus 1 now. Okay? And that's going to be, right? But you have to have something. I cannot say AR minus 2. Whose memory is going to go to? Right? You have to have the memory. But potatoes, potatoes. Everything's good. Or let's do something else. Let's do something else. C out. Oh. Right? 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 Okay, here, these are the same. Again, when you know the concept, everything makes sense. We know that the index of a variable is what it's going to be added to the address of the thing. If I put minus 2, it adds the minus 2 to p. There it goes 2 integers back. What's the difference? I have to have something over there, though. You cannot do it to any array. You are seeing one of your walkthroughs. It's a beautiful walkthrough right now, just like this. Okay? So that's how questions are going to come up in your test. Are we okay? And this was IPC 144. You should have known this now. Okay? Now we'll start. Okay? Questions? Suggestions? Objections? Yeah, I had an objection. I'm going to be slower. And please keep reminding, because I keep going. I'm sorry. It's a good thing I'm not a native English speaker. If I was a native, then I would be in trouble, eh? Okay. So now that we know this, so in here I'm going to say the true meaning or implementation true. What are arrays? What are arrays? And the comment for a gentleman who was kind enough who told me that your English is good, my friend, my English sucks. Like seriously, like don't see me typing because like 20 years I'm still like dictation. I'm really bad. Anyway, but thank you. It was really highlight of my day. All right. So we have these. This sync thingy is pretty good. If you open up sync in TortoiseGit, you can keep committing. So in here, I'm going to say, what are arrays, and review of pointers. One more thing I have to mention that actually it has to be recorded. I made a huge boo-boo, which was posting an announcement that workshop 1 is up and the due date is yada, 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 okay? today I was going over there, and I'm like, workshop for 345 is not up. What is this? And I noticed that the announcement I was supposed to send to 244, by mistake, I put it for you. I knew what the funny part was. People were asking me, I'm trying to submit workshop 1, and it's not going through. I know your names. It means you copied it from last semester. So that was an interesting trap that I actually laid for you. It was interesting. I'm trying to submit workshop 1 and it doesn't work. It's not up yet. I mean, how do you know what it is? Last semester. All right. Are we good? All right. So now we want to talk about, so arrays in, let me see what do I have for that. Okay, now we need to understand. So did we accomplish the fact that when I say employee pointer E, employee pointer is a type? We understand that, right? So employee asterisk together, that token means employee pointer, and it's a single type. Do we understand that? So because when you create a reference for it, people freak out. Okay? You can create a reference for any type. I can have an integer, and I can create an integer reference, right? I can create a car, and I can create a car reference. I can create an integer, again, integer reference. I can create an integer pointer, and I can create an integer pointer reference. It's just a variable. I want to have its reference. So when we see something like this, let's not freak out. You see that allo copy thingy that I created over here as a static thing? To do the allocation for this. So I have a class called name, and it has a dynamic name. It has mdata in it. And I want to allocate and copy in it, and I don't want to do it every time in a constructor, in the structure, in a move constructor, move aside. I don't want to do that. I just want to do it easily here. If I want to do something, I'm writing a function for it, right? But problem is that because it's a static function, it's a utility. It's a copy. It has nothing to do with name. Its job is to allocate and copy. This concept has nothing to do with the name. It's just necessary. Therefore, I created a static method in it. Now that I created static method, I no longer have access to mdata, correct? Because static methods cannot access non-static attributes. We just accomplished that. We just accomplished that? We just discussed it. Accomplish? What the heck? See? He jinxed me. Okay. Okay, so yeah. So now, if I want to do that, I want to be able to make mdata to point to something. If I want to do that, I have to pass its reference to somewhere. I cannot just pass its value. If I pass the value of an address, good job. I have where that pointer is pointing to. But if I want to make that pointer point to somewhere else, I have to be able to change its value. Therefore, I pass character pointer reference data, which means data at this place. You see line 15? At line 15, when allo copy is called, mdata is passed to line 7, and data, first argument, becomes a new name for mdata. And they're both pointers. Now, anything I do to data in that static void pointer, it happens to mdata. Mission accomplished. Okay?
When we say address of something, we just have the accessibility to the address, right? So we can change the value inside.
See, again, you are giving it extra credit. You have a variable. Variable has a value. When you pass its value around, you don't have access to the variable. You just extracted its value. What's the difference if it's a pointer variable or it's an integer variable? Variable is variable. If you want to change the integer, you cannot pass its value. You can either pass its address or pass its reference. Because it's already a pointer, people are going to freak out if I say integer pointer pointer, which we're going to do in 2 seconds. So we know what a reference is, so we use reference. We're going to say, this is a character pointer. I want to change it. I pass its reference. Easy breezy. Okay? Again, think of it as a single type. Say it as a simple type, and you'll be fine. Anyways, so that's a good example for it. It's a good example for why we need static methods. That's why when you have a method that is needed in your class, but it has nothing to do with the encapsulation of the class, you make it static. It means it belongs to class, not the objects. A name doesn't need allocopy. If I say, what is your name? My name is Fardak. You don't get there is an allocopy happening in me. It has nothing to do with me. It's not one of the features of name for the object orientation reason, for its abstraction. Therefore, it becomes a utility. Therefore, it becomes static. Are we good? Pointer reference. Review. Now, say I want to write a program that copies a piece of memory from one place to another place. Say I want to copy a piece of memory. I want to have 50 bytes from this location in memory to get copied to 50 bytes to this location of memory for whatever reason. I'm a hacker. I want to write a virus. Whatever. I don't care. It's not a string copy. It's not an integer copy. I want a memory dump from one place to another place. Okay? What is the smallest addressable unit of memory? A question for beautiful to see if people understand what memory is. You were saying? A character, which is a byte. So char in C language is byte. What is the smallest unit of memory? It's a bit. So addressable, byte. Well, if you say a char, everybody knows you're a C programmer. Say a byte, so you say, I know everything. Okay? Okay, so byte, which is actually a character in C. Are we good? Are we good? All right. So if I want to do that, then I need to write a function that receives the address. And because we know it's a character, character is the smallest thing, I can actually use something like this. Oh, what did I do? So I can actually say, OK, copy mem, OK, into destination, the address that I'm giving it, from a source, which is a constant, and the size. And one by one, I copy all the bytes, correct? So if I want to actually copy one thing into another, and it's a double, I have to cast it, right? Because it's a character. This is a double I'm copying. So, and character pointer something is not right. I actually have to say over here, reinterpret cast into character pointer, the double thingy over here, right? I think that was the syntax for it, right? And in here, I have to put the exact same thing. Because now we have type safety. That guarantees that the cast you are doing actually does what you want it to do. Okay? So I'm going to say completely reinterpret, because one is a double pointer, the other one is a character pointer. Two completely unrelated things. They are both addresses, but they are completely different things, right? We good? Are we okay? So now doing this ginormous thing, I can actually copy one double to another in a low level using their memory. Copy from the memory of one. So it actually, so when I actually run this program, It gets A and B, and it goes in here, and byte by byte goes through the contents of that thing, and 3 years later, 8 bytes later, it comes out, and magically we're going to have the value getting printed. Are we okay with this? Everyone? Yep. All right.
Teacher, there's a question.
Sure.
Is it program to only show two decimals after the point?
Yeah, because of the printout.
Okay.
Because of the fixed. Fixed.
And if we need the rest, basically we have to change the count, correct?
No, I'll show you. Give me 2 seconds. Copy mem using what? Using char pointer. Again, this is all C. It has nothing. Oh no, this is not C. The reinterpret cast is not C, but the rest is. Okay. So you were saying what? So in here, I have to, I think, say cout dot. What was that? Set f? No, what? Set f? Set f iOS fixed. What happens if I do it now? Let me see. Still the same? Oh, I edited the wrong thing. That's not the one that is being executed. Although I didn't change anything. It's possible that. See? Okay. So because if you don't say fixed, it means see whatever is more efficient, print it that way. So it decides how to print it. Okay? Are we good down to this point? Okay. Now, what I wanted in here was just an address, not a character pointer. If you want pure address, something that is only address with no type, you can actually do it. Instead of that, you can simply say void pointer. Okay? But the problem with void pointer is that when you put a void pointer, it's pure address. It doesn't know what the target is. When you have void pointer, you need no casting. You can put anything in it, as long as it's an address. The problem is that you have to move the casting up there. So in here, I have to have something like character pointer, or I can just do it over here. So I can put this one over here. And then the user does not need to care. So you implement it in a fancy way once, and the user now just can do copy mem with no casting. That's a void pointer. So what I'm doing, because it's void, I'm going to say reinterpret it into a character and treat it that way. Does that make sense? So left side of the index, now I have a character pointer because I casted it. So you put an index at right, it treats it like a regular character array. And the same thing for the other one. Why you look at it in such a sad way? Are we okay?
I'm trying to be.
I can make it easier. Let's do it like this. So I'm going to do it like this. I'm going to say character pointer, this destination is equal to const character pointer source is equal to Is that better? Didn't make any difference, does it? Yeah.
Just out of curiosity, that's the only way to determine the behavior of how much memory it moves?
I didn't get it. One more time?
Because you're using void, so void doesn't have a...
Doesn't know what is the size of the target.
Exactly.
I'm giving the size of the target to it by casting it.
Correct. My question is, if that's the only way to do so.
Yes.
Okay, that's all.
Yeah, okay. No, yes, that's the only way. You can do regular casting too if it was C. But I do reinterpret casts because I want it to be type safe. Yes.
So why wouldn't you use a void if you have to cast?
Because I do it once and no one else has to do it. A function is called millions of times, but it's written only once. So I suffer once, so other people are happy.
No, but I mean like the void that the void source. So that like I understand like the void function part. So like gives here you're casting like the destination and the source.
Mm-hmm.
So why are you using the pointer void in that situation?
Because void is pure address, it can accept any type of address. So nobody needs to worry about to cast it to anything, and therefore make it easier. So,
Would you use an auto instead?
no, auto doesn't work. Auto cannot work in an argument. Auto only works when you are creating and really initializing it. You can never use it as an argument. Okay?
It's a way to make the pointer basically type agnostic, kind of.
Yes, exactly. Yeah, nice. His English is better than me. Yeah, okay. Yeah, that's exactly what you're saying. Are we good? Are we good? Okay, so that one is copy mem using void pointer. So that's EFG. That's how I teach you what void pointers are. All right. You guys want to go for a break? Anyone? You want to go for a break? Oh, yeah, he says yes. Okay, he's just too shy to say it loud. Okay, break. So C++ is capable of detecting if an object is just about to die or not, or an object is a temporary object or not. Think about it for a second. When you have a term, like let's say you have the class name that we had, okay? And that name thing you have dynamic memory allocation in it, right? You want to, you read the name, so you have a function that reads the name from a file. So it creates an object called name and reads it from a file. And then you return that using the return statement to your program so that name is used. You okay with this? If you do that, you have to instantiate a name inside the function. It means dynamic memory allocation, all the good stuff. Then you have to return it out. And during returning, you know that copy constructor is called. So that's going to get copied into another object. Then the local object is dead. The copy is sent out to whoever's supposed to receive the name. And that is copied into the name that you have outside, and then it's going to die. So lots of objects has to get created or die. Think about dynamic memory allocation. What was dynamic memory allocation? With dynamic memory allocation, we had a class that had resources outside of its scope. So instead of creating an array inside the name with the full name of the person, I just create a pointer, and I put the name outside of the scope of the class in the heap where everybody's using it. Now, if I am sending this out to another program, and I know it's about to die, why do I copy it? Just think about it. You have the data outside of the class. So the other class must measure to see what is the size of this thing. Create another dynamic thing. Copy everything over there. Then this has to get destroyed and given back to the operating system. And the other one starts working. If this thing that is about to die is actually having dynamic memory over here, Why don't I just pass the address to the other guy and then kill the object instead of doing all the copying? Think about it for a second. I want to give you a cup of coffee, okay? Is it easier for you to have a cup and I empty my cup and give it to you, and now I have the cup, and then I throw mine away and then you use yours, or I just give you the cup of coffee? Essentially, that's what we have done throughout all OOP244. When we wanted to pass a coffee from one object to another object, that object has to create a cup, has to copy the information of the cup, take it away, not only it doesn't even pour this one. It brews a coffee exactly like this, identical to this, and uses it. Then I throw everything away, coffee and the cup and everything. It's crazy. Instead of doing that, why don't you just hand this over? Because I don't need it anymore. I'm about to die. I don't want to drink coffee anymore. We can do that. So this thing can be detected in C++. First, we learn how to detect it, and then after we detect it, we're going to change rule of 3 that my friend is going to tell me over here what it is. You remember what rule of 3 was?
Copy constructor.
Copy constructor. Give it to the next person. Copy assignment and copy constructor, copy assignment, and you remember? Destructor. Thank you. Yeah. You're very quiet. Get it aloud. Thank you. Okay, so we good? So we had rule of 3. We learned how to copy, we learned how to assign, copy assign, and we learned how to remove. After recognizing that an object is about to die, I can add 2 more things to this, make it rule of 5. It's called move constructor, which means instead of copying the data, I move the property of the other one to myself, or move assignment. When something is about to die and I'm assigning it to something else, I move everything from that one to this one, so the other one doesn't have the property. Therefore, the speed of our application is going to go exponentially faster. Instead of allocation, copying, deleting, all those stuff, I simply say, give it to me, and I'm gone. It's like those people who are running and passing the, okay? It's like that. Are we okay? So first, let's try to recognize what is temporary and what is not. And then after that, we can go through the implementation. Are we okay? Shall we begin? All right. That brings us to L value and R value. What does that mean when something is L value and R value? So this is an L value, left value. This is an R value, right value. That's all it is. Okay? An R value cannot or should not be at left side of an assignment operator. You follow what I'm saying? Say I have the, let me see if I can borrow it from somewhere. Say I have the class name, and let me include that C string over here, because that's CSTR that I did include. Yeah. So I have a name with a copy constructor, copy assignment, destructor, which is implemented incorrectly in my cheat sheet. Okay, I said the destructor is implemented incorrectly. Can anybody tell me why? So we're going to get to that. You answered correctly. We should have all our destructors always virtual. You're not allowed to have a destructor that is not virtual. Setting virtual is, so this should be virtual. That's the one. The second one. That's phobia. Okay? It's a good habit when you're a beginner. But when you're an advanced programmer, you know that the object's about to die. Who cares if it's 0 or not? You follow what I'm saying? It's like you have a disposable cup, and after you drink it, you perfectly wash it and then throw it away. You know what I mean? So it's good for OOP345, and I really appreciate it. Thank you that you actually said that. It means it's muscle memory. I delete, I set to null. That's perfect. But let's learn to understand why we set it to null, to flag it to be empty. That's what we do. If something is not needed anymore, who cares if it's null? So let's not do that. And believe me, you will see me do it. And you remind me, please, Fardat, don't do it. You told me not to. Okay? Because it's habit, right? So now I have this name thingy over here. I didn't implement anything. Do I have anything else over here? Yeah, I have a, let me have this one too. So that's displaying. And that's making the display working with cout. This is pure OOP345. We're good with this? Anybody have any question about it? That CSTR allo copy is the static thingy I created in the CSTR. So I don't have to do string copy, okay? Anybody have any question with this beautiful code of mine? We're good? All right. So what I'm saying is that if I say over here name, does it have, what does the constructor look like? And I'm not going to say null PTR, I'm just going to do this. If it's empty, it's empty. Safe empty state, right? Too much information. So yes, I have it that way, so that's good. So I'm going to say over here, name Fred, or yes. All right? If I say f is equal, if I say g is equal to f, we are good, right? If I say f is equal to name John, that's good, right? Everything's good, right? If I say name John is equal to G, is that good? Yes, it is. What's illogical? I'm creating a temporary nameless object that has John in it. I set it to G that is happen to be Fred. It overwrites that with Fred and it all die.
But we can say f is equal to g, right?
Huh?
But we can say f is equal to g.
Oh yeah, we can say f is equal to, sure, we can do that, yeah, no problem. Okay? You okay with this? Anyone? Are we okay? So this is an L value, this is an R value at line 34. 38, F is L value, that's an R value. It's a temporary object, but it's perfectly valid. Sometimes R values are hidden, by the way. I can do this. Okay? What's happening at line 42? Can anyone tell me? What's going to happen at line 42? I did not overload any assignment operator that accepts constant character pointer at right. I only have a copy constructor, copy assignment, and a destructor and a display. But no error. It works perfectly. Can anybody tell me? In OOP345NAA, we talked about 4 different types of polymorphism. Remember what it was? You remember what it was? You remember what it was? We had 2 major types, universal and ad hoc, right? And then each one of these had 2 types. Ad hoc has 2 types. What are the 2 types? Seriously? You just... One was coercion, and the other one was overloading. Right? What was... Overloading is overloading. What was coercion? We said there is polymorphism that is a side effect of coercion, which is essentially casting. I can say a double value like double A and integer B. I can say A plus B in C language. A is double, B is integer. What does it do? To make that plus happen, it upcasts the B to a double, does the math, and returns it, right? You okay with this? Line 42. I have H, and I have a constant character pointer. Does the compiler have the tools to convert a constant character pointer to a name? The constructor. The constructor literally gets a constant character pointer and makes the name out of it, right? So line number 38 and line number 42 are identical. In line number 42, it's as if I'm saying H is equal to name Henry. So when it comes over here, so let me just walk through it for you so you see. If it runs, of course. 4 years later. Oh, okay. So it's right over here, right? I'm pressing F11. See where it goes? Constructor. What is the value over there? Henry. So it auto-copies and everything. A constant, a temporary value is created. Now that the temporary value is created, it goes to assignment. So this N over here is actually name of that temporary nameless object. Reference of a temporary nameless object. It gets copied and passed. See how much waste is being done. It's being copied and passed into H, and now that it's done, it goes to destructor and deletes the Henry, the temporary nameless one, and comes back, and now H is there. So how much waste it's done. If I could detect that that damn thing is supposed to die, instead of doing all the allocation, schmallocation, I could simply say, okay, take the Henry and be done with it. Still, the destructor of the other thing is going to be called, but because it lost its memory, we set it to null and we're done. Okay, so how do we actually detect all these? GHI, R values, and L values. There is no comment in there, so hopefully you listen and then you go over there and you see what it is, right? So actually, let's do this. Remember I told you when you go to washroom, you do a commit and say going to washroom? That's what it is. So open sync and keep doing that, okay? All right. So that's that. Let's come back over here. Now, we're going to use those things later, but let me come over here. So an L value is identified by reference, which means if I have something like this, I'm going to say, what do I say? What do I say? Void, I'm going to say which value. In here, I'm going to say integer reference L value. Okay? And I'm going to say C out L value is the L value. Okay? And now I'm going to create the same thing. And instead of a regular reference, I'm going to put an R value reference. There are 2 ampersands. R value and R value. Now in here, I'm going to say integer I is set to 10, right? Now I'm going to say which value? I. Which value? You run the program, we get an error. What is the error? Oh, R value. Sorry. See? So now the compiler can detect which one is a value that is an L value. It's not about to die. It's something that's going to stay alive. If it goes over here, that's the L value. But this one is a temporary value. It doesn't have any substance. It's something that's just a temporary thing. And that's that. That's the R value. Now, we can do the exact same thing with the in here, I'm going to say name reference N, L value, C out L value. And I can do the exact same thing for the R value of it. And I forgot that again. Right? And now I can actually say name N is equal to Fred. Now I can say which value N and which value name Jack. And when you run it, you'll see that it actually, you'll see that it actually recognizes which one is what. Do we understand that now? Okay. Now, if you want, you can actually force something to be passed as something else. So I can say over here, which value? And in here, I can say move N. Now, if you look at that one, you'll see that it actually goes to R value because I said move. So you can force an object to be passed by the other thing. We okay with that? And I can actually say, let me see if that works. Ref. It didn't work. It's a deleted function. Yeah, it doesn't, because it's about to die. I cannot pass its reference to it. It's going to die. But anyways, ref is the one that you can actually set it to be a reference. Make sure that it's a reference that is passed. Why it didn't work out? It should work. Yeah. Anyways. So yeah, so the other, which value, which, I want to see if I, of course that's okay because it's a reference already. And when I develop the name, then I'm going to show you. Okay, so for now, let it be like that. So that's ref and move. So you can specifically ask for it to pass it in a specific way. And yeah. It passes the reference of it, not the move reference. So when it's called, it calls this one, which we're supposed to. Let me just try something else. Now, because now it's character pointer. Why it didn't work? Yeah, I don't know. I'll find out and I'll let you know. Okay. So now that we have a way to detect this, let's run it over here. Okay, so let's call this ABCFGHI. I'm going to call this R value and L value references. So essentially, they call it this. This is an R value reference. That's literally its name. This is a reference. This is R value reference. Are we OK with this? OK, now take a look, see what am I about to do. Take a look, please. Attention, 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 Achtung. OK? Take a look at this. So I have copy constructor and copy assignment, right? Not here. I'm going to do it here. I have copy assignment and copy constructor. What if I bring this one down here and I say, oh, that's not copy constructor. Did I create a copy constructor at all? Or I forgot? No, I forgot. I didn't do copy constructor. I just had an assignment and a constructor. So that's the copy constructor, right? That's the copy constructor. Now, I'm going to take the copy constructor and bring it right over here. So I have rule of 3 down to this point. Now take a look. I'm going to make it 2, and I'm going to remove the constant. What does it mean? It receives the reference at the right value reference of an object, and unlike copy constructor, is allowed to change it. Don't forget it's a reference. You can still change it. Now, in here, I'm going to check if the n value exists. Instead of allo copying, what I will do over here will essentially be saying m value of this object is equal to n value. I'm not copying anything. I'm just taking over of the data of the other one. So the m value, nm value, that was pointing to the data of the other name is now I am pointing to it. And then what I will do, I'm going to set that one to null PTR. So I literally get the data of the other object and tell to the object, you have nothing. I got yours. So I literally take over their data. See, no copying is happening at all. The difference is that, I'll show you, when you move a name, you will see, if I have a name Fred and I have another name, when I move it, this one becomes Fred and that one becomes empty. Okay? Because it just loses its data. And it's hundreds of times faster. If I don't need the original one, day one, do I need to do that? Why do I need to ever copy? And I can do the exact same thing for the assignment operator. Where's my assignment operator? So this is called move constructor. Now, in here, I'm going to put that one. And what I'm about to do is exactly the same. I'm going to say, get that one, change it. But remember, this is an assignment operator, which means I might have data. I might have data. So first I have to wipe mine out. Delete mine. Now that I don't have anything, we don't set it to null because I'm just going to overwrite it. I'm going to say mValue is set to n.mValue. And n.mValue becomes null PTR. I deleted my own. I took over the other ones, and I emptied the other one. Now, take a look and see what happens. Actually, let's mention that what we have. So this is n, and this is f. You okay? So if I run it 3 years later, oh, we have Fred and Jack, right? Are we okay with this? Now see what I'm going to do. I'm going to say n is equal to move f. So by doing this, I am passing an rvalue reference of f, right? So this is what's going to happen. Take a look. So I have these two. It comes over here. Now it goes to move. Now it comes over here, right? Now it deletes Fred. This one is pointing to Jack. This one is garbage. Now this one is pointing to Jack. That one is pointing to Jack, both of them. I'm going to set the other one to null. Now I go out. Now n will have Jack, and f is empty. I move the data from that one to this one. And when I print it, you will see that f has nothing. Ta-da! Pardon me? Oh, yeah, oh, sure. We okay with this? So the good thing about all these is that now you don't have to worry about when it needs to get copied and when not. Relax. Pass objects by value. Pass objects who has rule of 5 by value. Don't worry. Because temporary objects are being passed, anytime it's temporary, it's going to move it, not copy it. Therefore, it's going to be faster. Okay? Also, I have to remind you of something. If you are to reuse your assignment operator in your move assignment, if you want to reuse your move assignment in your move constructor, you have to make sure you move it. What I mean is this. if in here I'm saying operator n, I want to reuse my operator, right? You have to make sure you move it. Otherwise, it's going to call the other one. Okay? Because it doesn't know if it's a temporary or not. You pass it once. It guarantees that it's moved. So if you are doing move constructor, make sure you call move assignment in there if you are using code. Are we okay with this? That's rule of 5. All right? If you look at the notes, it's a little mishmashed because move construction and stuff are done in, I think, the next chapter. But because they fit together with R value and L value, I like to teach them back to back. So if you see it's out of sequence, just go find out where it's teaching it and see that one. Okay? The next day you are coming in, we're going to continue with range-based for loops and nameless structures, unions, aggregate initialization, pointer to pointers, and all the good stuff like that. Okay? Are we good? Questions? Yes.
This is like an optimization of managing outside resources.
Yeah. That's why I said in OOP345, remember I said, now you're doing rule of 3, you're going to do rule of 5, and that's what I'm talking about.
But why do we have to keep the copy constructor? I think that's why you still have to keep you still have to define the copy constructor, right?
Because it has resources outside of its scope. It doesn't know how to handle it. You have to tell it how to handle it. It has a pointer m value that is outside. If you don't mention it and it optimizes itself, it only copies the pointer. The other one remains with the same thing, and the destructor is going to delete them both. Remember, rule of 5 from now on for any classes that are doing outside of it. And this is a question for your midterm. No doubt you will have it. I'll tell you, this is a class, implement rule of 5. I want to see if you can do it or not. No questions asked. It's going to be there. Okay? While I'm packing, I'm going to ask you a question. What are you guys feeling about dividing midterm into 2 pieces? 1 concept, 1 programming. I'm not going to add to the number of questions. I'm just going to add to your time. So instead of having in one session 1 hour and 30 minutes doing concept and programming, in last 2 labs, 1 lab I'm going to ask you concept, test for an hour. The other one I'm going to give you programming for an hour and a half. Think about it. No. No, by the time we are at week 5, we have enough stuff so I can go through concept. Okay? So yeah, so concept is going to be, so it's going to be last 2 weeks the midterm is going to happen. One is going to be, the first one's going to be concept, second one's going to be programming. Think about it, okay? Think about it and then you're going to answer it, okay? All right, I'm just going to comment this one. And you know what? When you're going home, please do me a favor and get this program, okay? And start creating functions that return name by value. And then pass it to another function that prints it by value instead of passing by reference. See what happens. Like create a function called print that receives a name by value, and then you pass something to it by value and see what happens. See move action happening on the fly, and you see how things are happening, okay? All right. Yes? One more time? No, it's not shallow copy. Yes, you are doing shallow copy of the pointer, but remember the pointer of the other guy is pointing to where the data is. So you are doing a shallow copy. Because of that, you are going to point to his data. But the difference between shallow copy is that you don't delete the other guy's data. In this one, you do. First, you do shallow copy, then you terminate the link of the one that you're copying to the other one. You're absolutely right. It's a shallow copy and then termination of the data of the other one. Thank you. Yes, sir.